All right. Last question that finally, after third normal form, there are there are four relations. The original table becomes lab test. Patient lab contains patient ID, lab test ID, lab test date, and lab test result. And all these are foreign keys. So this is not foreign key, primary keys. We have three attributes together as a primary key. And then we also have a lab test, contains lab test ID and lab test name. We have insurance, contains insurance code as primary key, and then insurance name field. And we have patients, contains patient ID as primary key, and then name and insurance code, insurance code and date of birth. And then we have another table called insurance table, contains insurance code as primary key and insurance name. So that will be, originally we have a flat one table, one relation. After normalization, it becomes four relation. As you can see, if you are removing a patient, and actually you just remove patient information and the insurance information doesn't get hurt. So you don't have any deletion anomaly. If you are adding a new patient and you just type it once, so you don't worry about your value, you don't worry about the typos, but you enter a new patient with the test. And if you are modify patient information, actually you just need to modify one row, which is patient table. So that eliminates anomaly of deletion, insertion, and modification. Now the second question is, you want to draw an ER diagram, so that when you convert the ER diagram into the relations, it will be four relations like this. Like these four relations. So what I'm going to do is I create, so from here you can tell the major relation is patient, insurance, and lab test. This is actually patient with lab together. So this is not a, we are doing a reverse engineering. This is not a real entity. So I create three entities, which are patient, lab test, and insurance. That means they exist independently. Then, from patient to lab test is one patient. Means if you pick up any of the patient from the patient entity through hasp relationship, they can have zero or more many tests, because one patient can have the same test on different dates. If you pick up any of the tests, it's going to be performed by many of the patients. This is actually is many-to-many relationship, but each hasp relationship, you can put a lab test date, indicate when the lab test is performed. Now you also create insurance. That means a patient can have an insurance. And one insurance, like Blue Cross Blue Shield, is owned by many of the patients. So this is a one-to-many. A patient, pick up the patient, they can have one insurance. Pick up the insurance, they can have many of the patients that have this same insurance. Same as this. Right? You pick up the lab test, it will be performed by many of the patients. You pick up the patient, they can have zero or more lab tests on different dates. Okay. So I put a lab test dates as the attribute for this relationship. So if you convert this, you are going to get a table, because for patient we have one relation, patient ID, patient name, because this is many side, so many sides will carry the primary key on one side according to our conversion algorithm. Let me just show the conversion algorithm. So we have conversion algorithm in your term project link. right? And then the conversion algorithm says that how to convert the ER model into a relational schema. So we can just come up here. Let me copy the link address, and then we can paste it. And you come to the web page, and they will tell you how to convert a ER diagram to relational model. And you go to next page, and here says converting a relation. So for one-to-many relationship, this is one-to-many relationship, we'll copy the key of the parent, which is one side, to the child side relation, which is many side. So one side, customer, you have the customer table, customer ID, names, attribute, and form. But many side, which is, this is the many side, you have many. You have order, so you order relation, not only you have order number and salesperson, sales and order date, and you also including the one side, which is primary key of one side, which is customer ID. You put it here. This is called one-to-many. For many-to-many, what's happening is you still create a supplier, your supply ID, first name, address. You also create a relation, which is product relation, the product ID and description. And because this is many-to-many, so we will create a new relation called product supplier that contains that include the primary key of both sides, which is supply ID and primary key or product ID together as a primary key, but individually each of them is a foreign key. But these two together is a primary key. So this is called a conversion algorithm. And if you come back here, you come back to our equations. So because this is many-to-many, so not only you have patient table, lab test table, but also you will have a new table called patient lab that contains lab test dates and the result. Of course, this is result. I forgot to put the result. There's no space, and then in the center. So each patient has a lab test, and this is a lab test. One is to perform the lab test, and also what is the result. So these two together is a foreign key. So when you want to convert this into a relational model, you will create a new table called lab test date, and it's called patient lab, including the primary key or patient ID, primary key or lab test ID, and then lab test date, and also the result. So this is the final result. You have patient entity mapping to a patient table, lab test mapped to a lab test table, insurance mapped to a insurance table, and then because it's one-to-many, so this is the one side, many side will receive the primary key of one side. So patient table, you got to include the insurance code. And this is the many-to-many, so we are going to create a new table called the patient lab that contains primary key from patient ID, and primary key for lab test ID, and also the lab test state together as primary key. So you will have, after you convert, you have 4 different tables. Okay, this is a discussion of our final SAM practice. Right, thank you.